All right, everybody, welcome to the video here where I'm going to go over the answers shown out for the August 2022 Algebra 2 Regents exam. So for this video, we're going to do the questions in parts 3 and 4. So taking a look at number 3, we have a function here that's being described about researchers and microscopes. It gives us an initial amount of bacteria, and it tells us that it doubles in population every 20 minutes. So we're going to use kind of a variation of the half-life equation, but instead of half-life, we have a double life. So we have some information here that we can use. So the basic formula that we're going to have here is the ending amount is equal to the principal or the initial amount of bacteria times 2 since we're doubling, and we're going to make it to the time divided by however much time it takes to double, which is 20 minutes. So that would be over 20. So let's use our function the right way. So it says assuming this initial amount, write a function p of t. So we're going to call this p of t. And that's going to be equal to the initial amount of bacteria, 11,000 times 2. And since t is minutes and it's 20 minutes for the double life, we'll say t over 20. That's all you got to do for that first part. For the second part, it says using p of t from part A, algebraically determine to nearest hundredth of a minute the amount of time it takes to get to 1 million bacteria. So we're going to replace 1 million where p of t is. So we're going to say 1 million, make sure you have the right number of zeros, is equal to 11,000 times 2 to the t over 20. Now, since our variable's in the exponent, we are going to have to use logarithms here. Now, before we can do that, we have to first get the 2 to the power by itself. We have to get the exponent piece by itself. So we're going to divide out the 11,000 to both sides. So if you divide that, you don't get the nicest number, but it does reduce to a fraction of 1,000 over 11. Remember, we don't want to round here, so if you can't get a nice decimal, just use the fraction. Now to continue here, we're going to natural log both sides. So we'll say the natural log of 1,000 divided by 11 is equal to the natural log of 2 to the t over 20. And using our properties of exponents, we can take this exponent of t over 20 and put it in the front. Because we remember that if we have a logarithm with a power in it, we're using the power to power exponent property here. Because remember, logarithms are just exponents. So we could say the logarithm here of 1,000 over 11 is equal to t over 20 times the natural log of 2. Now our job is to get the t by itself. First thing I'm going to do is multiply both sides by 20 to get rid of this fraction. That's going to make our life a little bit easier. And then we could divide both sides by the natural log of 2. So we're going to get that t is equal to 20 times the natural log of 1,000 over 11 divided by the natural log of 2. And then it just becomes a calculator problem. So you can take out your Desmos and type that in exactly how you see it with your fraction, and you're going to get 130.13 minutes. Not too bad. Okay, so for the next one, it gives us a function, and it wants us to graph it over a domain. So one of the things you have to understand is when there's a restricted domain on our graph, that means we have no arrows. Don't be that person that gets points off because they draw arrows when there is a restricted domain, right? We know that. So let's grab some Desmos action here and see what we got. So let me just get rid of whatever I have in here and move this thing because we don't need it. And we are going to call this what it's called. So we will say v of x is equal to, and it is x times 3 minus x and x plus 4. If you put some brackets after that and tell me where you're restricting your domain, basically write the restricted domain exactly how you see it on your paper, it'll actually just graph the section that you want. This is all I want to put on my graph. Okay. So we can see there's a maximum at this decimal. And if we hit the little gear button, we can create a table, and we can make our table go a little bit bigger because we have to get up to 3, and we have some points that we can graph. So the first thing I'm going to do is I'm going to point the whole number, graph the whole number of points, and then I will estimate approximately where that maximum value is so that we get a nice sketch that we can go through. So we have 0, 0. We have the point 1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have the point 2, 12, and 3, 0. Now, some students will just go through and try and make a curve out of that, but we want to estimate where that maximum is so we get a nice graph. So since this is 1 and 2, each one of these is going up by a part of that. So we'll have like 1.2, 1.4, 1.6, and 1.8. Now our maximum, if we go back to decimals here for a second, if we just click the graph, is at 1.7, 12.6 approximately. So 1.7 and 12.6 will be a little bit above 12 here, almost to 13. That'll allow us to get our maximum, so we know our graph's going to come down from there and down from here, and that's going to be approximately what a good graph would look like. It then says to nearest tenth of a cubic inch, what's the maximum volume? So this is asking us for the y value, right? Because if you remember, the x value is not the volume is the y value. So this is v of x on our graph, right? So our maximum volume is going to be at 12.6 cubic inches. All right, moving right along to the next question. It gives us two functions and it wants us to find the quotient. It is just asking you to divide here, right? This expression is just telling us to divide, find the quotient, and then add the remainder over the original thing that you divided by, right? It's the same thing you've always done, it's just showing it in a weird way. So let's make boxes. We'll say x minus 4. We're trying to create f of x inside the boxes. So the first thing we'll put in there is 3x cubed. Well, if that's 3x cubed, we have to ask ourselves what multiplies by x to make that, which would be 3x squared, which tells us we need a column for x and a column for constant. I then get negative 12x squared here. And we know the x squared terms we want to add up to negative 4x squareds. So then we have to think, well, what do we have to add to negative 4 to make, negative 12 to make negative 4? That would be positive 8x squareds. So then x times 8x would make 8x squared, which would make this negative 32x. But our x terms want to add up to 2. So we got to make this 34x, which would make this 34. And if you multiply 34 times negative 4, you get negative 136. Now to find our remainder, we're going to take this number in the last box, and we're going to say what adds to that number to make the negative 1. So we're going to say negative 136 plus some remainder is equal to negative 1. So if I add 136 to both sides, add 136 to both sides, we get a remainder of 135. So to write our final answer here, we're going to write our quotient, which is 3x squared plus 8x plus 34. We're going to add the remainder, which is 135, divided by the divisor, which is x minus 4. That is my answer. The second part asks to explain why x equals 4 is or is not a root of f of x. Well, since I divided by x minus 4, by evaluating x equals 4, we're using the remainder theorem to test whether or not this is a factor or not. If x minus 4 is not a factor because f of 4 does not equal 0, which means x equals 4 is not a root. Now, how do I know that? Well, since I have a remainder when I divided by x minus 4, it tells us that it's not a factor. If it's not a factor, that means its solution can't be an actual solution to the function, meaning it's not a root. Moving right along. I don't know why that popped up. Let's see. All right, so we have this state official. We have a bunch of information here in this opening paragraph explaining how we created our simulation. So we're creating a simulation around the fact that 82% of the community wants to repeal the 30-mile-per-hour speedway, and we are going to re-simulate that thing 200 times, meaning there are going to be 200 dots in this potential distribution. Of the dots, the average of all the dots is 0.819 or 81.9%, and the spread or the variability of your dots has a standard deviation of 0.053. So based on the simulation, so as soon as you see that, you know to use this information, right? So based on the simulation, we want to contain the 95% plausible proportions. This is the confidence interval. So we could say the confidence interval is going to be the mean of all of the sample proportions plus or minus the margin of error. So we can find the margin of error first. So we'd say the margin of error is 2 times the standard deviation. And the margin of error is going to be 0.106. So this 95% confidence interval we're going to get by adding the mean of all of the sample proportions in the distribution to the margin of error. So we're going to add and subtract that margin of error, and we can create our interval. Now, when you create your interval, make sure you round it appropriately. They like to change from 1,000th decimal place to 100th. Sometimes they've even used a 10th. So if we subtract them first, because remember you want the smaller number first, you get 713. If you add them second, you get 925. This is our 95% plausible interval. It then says that the community organized and conducted its own sample survey and found that 70% of those supported want to repeal based on a simulation. Explain why the organization should question the state's claim. Well, we're going to question the state's claim because 70% is not in this interval. So it would be an unusual result, right? So this sample proportion that this community has is 0.70, is not within the plausible interval. Meaning, according to the state's claim, this is unusual. Something along those lines would be good credit for that question. All right, moving right along to the next problem, the part 4. So remember, part 4 questions are worth the most points. They're worth 6 points. There's going to be a lot of things that you have to do for this question. So first and foremost, you have to graph two different exponential functions, and they're a little bit funky, right? There's going to be some decimals. There's going to be some estimating of points that we have to do here. Luckily for us, they give us the scale, so we just have to kind of follow the scale and go from there. So I'm going to go to Desmos here and graph this so we can see what it looks like. I'm going to get rid of this stuff, and let's graph this. So the first one was called A of X. And it was 15.7 times 0.98 to the x. Second one was called B of x. And we will set that equal to 11 times 0.99 to the x as well. And I'm going to recreate the scale that they have on paper. So the y values went up to about 20. and the x values went all the way out to 100. So this is what we want our graph to look like essentially if we scale it correctly, right? So we should have something that looks like this on our paper. Okay, so we have this, and we can create tables of values from here. So we can hit the little gear button, we can make a table of values for A, we get the little gear button and make a table of values for B so that we can graph this all the way up to 100. So it's going up by tens. So we want to go 10, 20, 30, 40, and keep going. And you can see where your points are all going to come up on your graph. 70, 80, right? All you're doing is typing in numbers. That's all you're doing. Not 900 and 100. And then we want to recreate this graph on our actual graph paper. So 15.7. So 0, 15.7 is going to be up here. And it's going to take a little bit of a while, but it's okay. 10 is at 12.8. 10 is at 12.8, so almost a 13. 20 is at 10.5-ish. 10.5-ish. Notice I'm ignoring all the other points. I'm just graphing the ones that they're telling me to graph. 30 is at 8.6-ish. 30 is at 8.6-ish. 40 is at almost 7. 40 is at almost 7. 50 is at 5.7. So almost 6. Let's see. 60 is at 4.6. And you can see it is somewhat exponential decay. 73.8. 80 was a little bit more than 3. 90 is at 2.5, and 100 is at 2. 90 is at 2.5, and 100 is a little bit more than 2. Now notice it does give us an interval again, so we want no arrows, right? So when I connect these points, I am just going to connect from this original point, make a nice smooth curve through my coordinates I graphed, and stop. And I will label this as A of X. And then I'm going to repeat the process for B. So we'll go down to B. Let's see, where are you, B? Here we go. So we'll put in 10, 20, 30, 40, 50, 60, 70, 80, 90, and last but not least, 100. All right, so at 0, we're at 11. At 10, we're at 9.9, so almost 10. At 20, we're at almost 9. At 30, we're a little bit more than 8. At 40, we're a little bit more than 7. At 50, we're 6.7. At 60, we're a little bit more than 6. Five and 4.9, so we'll say 5-ish. 4.9-ish. I don't know, it was 5 point something. Right there. 5.4, yep. And 4.5 and 4. 4.5 and a little bit more than 4. So we'll see again a nice smooth curve down through our coordinates. I'm going to label this guy B of X. Next question says, the nearest x value, solve the equation when a of x is equal to b of x. Notice it does not say algebraically. Do this on your graph. So we're going to do this graphically. If you're worried about showing work, just say they intersect at and tell me the coordinate and then round your answer. So they intersect at the coordinate, if you click them, 35.043 and 7.7. So we'll just say 35.0. So 35 comma 7.7. So we'll say x is equal to 35. That's all you had to show for full credit there. For the next question, it says to the nearest minute, subtract b of 100 minus a of 100 and explain what this represents in the given context. So b of 100, we know that value because we just found it on our table. So b at 100, let's see which one is b. So b at 100 was 4.0264. 4.0264. And a at 100, again, we know that it's right on the table. So if we go to a, it's 2.0821. If you subtract those, b of 100 minus a of 100 is going to be equal to 1.9443. It says to the nearest minute, so that would be 2 minutes. So what we can say here is when both have 100 customers, plan B is 2 minutes quicker than plan A. No, not quicker. Sorry. Longer. That would make more sense. And that's it. Hopefully this video helped. Hopefully you're just checking your answers through this video and you're getting a lot of these right. Regents exam is fast approaching. So keep trying, keep practicing, and you'll be okay. See you soon.